Today we're going to learn about experimental and theoretical probability, and we are going to make a prediction using both of those. I think that you'll find, whether it's experimental or theoretical, the idea is the same. One just depends on if you do an experiment, and the other one just depends on if you use what information is given to you. So I think you'll find that there's not much difference between the two, but let's go ahead and define some vocabulary. First vocabulary word is experimental probability. Experimental probability is probability that is based on repeated trials of an experiment. So experimental has the word experiment in it, so I think that you can kind of make that connection. And then here's what it looks like. So the probability of an event is number of times the event occurs, and I'm going to run out of room. That's occurs. Number of times event occurs, and that's over the total number of trials. And we'll look at some examples, and this will start to make sense. So theoretical probability is when all possible outcomes are equally likely. We've kind of already dealt a little bit with that. We just didn't call it that at the time. So the probability of an event occurring is number of favorable outcomes. That should sound familiar. And that's outcomes, if it doesn't look like it, over the number of possible. Outcomes. So we have been dealing with theoretical probability. So relative frequency is a fraction or a percent of time that an event occurs. So here's how we write that. Relative frequency is number of times event occurs over total number of times you conduct the experiment. This should look very similar to experimental probability. So you might check your definition of experimental probability and relative frequency, and kind of start figuring out, how they're the same, because they are. Okay, so relative frequency equals the number of times the event occurs over total number of times you conduct the experiment. Let's go ahead and look at an example. Example 1 says find the experimental probability. The bar graph shows the results of rolling a number cube 50 times. What is the experimental probability of rolling an odd number? So the probability of an event is number of times the event occurs over total trials. So there's my my algorithm, and we want to know the probability of rolling a odd number. So what I'm going to do then is an odd number. I rolled a 1 10 times, I rolled a 3 8 times, and I rolled a 5 11 times. So this is 1, this is 3, and this is 5. And I got these numbers from my chart, my bar graph. So 10, 8, and 11, I'm going to add that up. and I get 29. So it occurred 29 times out of 50. It's given in my problem. Then on my calculator, I'm going to divide 29 by 50. That comes out to be 0.58 or 58%. So the probability of rolling an odd number is 58%. Make sure that you understand how I got these numbers right here, because that's going to be important for when you do your homework. So if you're having trouble reading the bar graph, come see me and I'll help you figure that out. Okay, so let's look at example 2. We're going to make a prediction. It says that it rains 2 out of the last 12 days in March, except this calendar says April, so we'll go with April. If this trend continues, how many rainy days? Oh, no, that's right. It rains 2 out of the last 12 days in March. If this trend continues, how many rainy days would you expect in April? All right, so we're looking at the probability that it rains in April, and so that is, let's see here, how do I want to set this up? So the probability is 2 out of 12, and I want to know how many days it's going to rain. So this is rain, and this is total, I guess. And then if this trend continues, how many days is it going to rain if there are 30 total days in April? This should look familiar on how we solve it. Cross the equal sign and multiply. Cross the equal sign and multiply. Then I'm going to divide both sides by 12. 60 divided by 12 is 5. So if this trend continues, there will be 5 rainy days in April. And that is my answer. All right, you have some on your own problems. Go ahead and pause the video, and you can do the on your own problems and then come back and check your work. All right, so it says example 1, what is the experimental probability of rolling an even number? Well, there's 2 ways to solve this. In example 1, we found out that it was 58% of rolling an odd. So one way to do it is just to take 100 minus 58 equals 42%. So I have a 42% chance of rolling an even number. The second way to do it is to add up those numbers in that chart like we did for odd. And when you do that, you add up the evens and you get 21 out of 50. Then on your calculator, you can do 21 divided by 50, and that comes out to be 0.42, which is 42%. And it makes sense that if I do it 2 different ways, I should get the same answer. All right, let's look at example 2. Example 2, it says, at a clothing company, an inspector finds 5 defective pairs of jeans in a shipment of 200. If this trend continues, about how many pairs of jeans would you expect to be defective in a shipment of 5,000? All right, so we are looking for defective. So this one, we're going to make a prediction. And 5 are defective out of a total of 200. And how many would you expect? So that's what I'm trying to find, out of a total of 5,000. So on your calculator, if you haven't done so already, cross the equal sign and multiply. Cross the equal sign and multiply. Then I'm going to divide both sides by 200 to get x by itself. And when I do that, x comes out to be 125. So I can expect that there would be 125 pairs of defective jeans in a shipment of 5,000. So notice how we're taking something that we have learned, our proportions, basically, and using them in a different way. Example 3 says find the theoretical probability. You randomly choose one of the letters shown. What is the theoretical probability of choosing a vowel? So in these group of letters, E and O are my vowels. And I want to know the probability of choosing a vowel. And I have, I guess, 3 E's. So I have 3, 1, 2, 3, out of 1, 2, 3, 4, 5, 6, 7, out of a total of 7. So on your calculator, you're going to do 3 divided by 7. And when you do that, it comes out to be about 43%. I think you have to round it just a little bit. So you have about a 43% chance of choosing a vowel. You should be trying to work these on your calculators so you know what you're doing, so you know how to do it when you're doing it on your practice. Alright, example 4 says the theoretical probability of winning a bobblehead when spinning a prize wheel is 1 out of 6. The wheel has 3 bobblehead sections. How many sections are on the wheel? Alright, so I have the probability of an event is how many it occurs over total. So this here is my probability. This is how many times it occurs, 3, and then I'm trying to find how many sections are on the wheel. So I'm going to use my cross product property, cross the equal sign and multiply. 1 times x is x. Cross the equal sign and multiply. 6 times 3 is 18. So there are 18 total sections on the wheel. And that's my answer. Alright, you have some on your own problems. Go ahead and pause the video and then do the on your own and come back and check. It says the bar graph shows the results of rolling a number cube 300 times. What is the experimental probability of rolling an odd number? So we want the probability of rolling an odd number. And I'm going to add those up on the calculator. 48 plus 50 plus 49. And when I add those up, I get 147, and then the total is given in the problem. So there's 300. So I'm going to divide 147 by 300, and that comes out to be 0.49. So I have 49% chance of rolling an odd number. Part B says, how does the experimental probability compare with the theoretical probability? Alright, so the theoretical probability is 50%. So experimental probability at 49% is very close to theoretical probability, and that's what you would expect. The more times you roll a number cube, the closer you're going to get to the theoretical probability. Part C says compare the experimental probability in Part A to the experimental probability in example 1. What do you notice? And it's pretty much what I just said. Alright, so here is how I worded it. The more times you roll the number cube, the closer you get to the theoretical probability. Go ahead and work that last on your own problem and then come back and check it. Alright, the on your own says use the bar graph from above to find the experimental probability of rolling a number cube greater than 1. Compare the experimental probability to the theoretical probability of rolling a number greater than 1. So the theoretical probability greater than 1 would be 5 out of 6, because you would have 2, 3, 4, 5, and 6. So you have 1, 2, 3, 4, 5 out of 6 numbers. And when you calculate that, 5 divided by 6 is 83 and 1/3%. Alright, you should check that on a calculator. Then the experimental probability, you're going to add those numbers up from your bar graph. And when you do that, you should get 252 out of 300. 252 divided by 300 is 84%. So theoretical probability and experimental probability, they are both very close, as they should be. All right, if you have questions after watching this, please come see me.